Hi all. Now we are going to discuss about linked list. Linked list is actually a linear data structure where each element called node contains two parts. So one part is actually data and the second part is a pointer. Pointer is nothing but the address of the next node. So unlike arrays, the list of arrays or list in Python, elements in a linked list are not stored at continuous memory. Okay, so now we are going to discuss more about the linked list. So there are three types of linked list: single linked list, double linked list, and circular linked list. Coming to the single linked list, each node points to the next node in a single direction. The node which contains only one element and next part is actually the address of the next node. Coming to the double linked node, each node will maintain the two pointers, means two addresses. One is the address of the previous node, another one is the address of the next node. So coming to the circular linked list is also all the nodes are connected in a singular manner or double manner, but finally the last node is connected back to the first node. That is actually a circular node linked list. Now let us know more about a single linked list. Now let us see how to create a simple linked list using Python. Now you can see the single linked list structure here. The node A, there are two partitions A and the next partition is called the address. That is actually that is managed by the operating system. No need to remember the address. Just you can see what type of data we are going to store. A is an actual data and the next partition is an address of the next node. And coming to the B is the data and this is the part of the address of the next node. Next C is the data and C stores the address of the next node. And D is an actual data and after that there is no node, so that the last node will maintain the null, because null indicates that that is the last node, because there is no other node to store the address of the next node. So now here there are two pointers. One is a head pointer which is always pointing to the first node. First node is actually store the address in a head pointer. Now null is actually pointing to the last node, because if this is the last node, the node next is nothing, so that it will be represented with the null. Now you hope you understand the linked list is having the two partitions. This is a simple linked list or it is also called as single linked list. So single linked list only two partitions. One is an actual data, other one is the address of the next node. For example, if there is no next node, the address of the node will be null. So this is the last node. D is the last node. There is no other nodes afterwards, so that it will be represented with the null. Now you understand the representation of the single linked list. Now how do you create a linked list? Now here, after creating a linked list, we need to follow some methods here. Okay, first we need to use a constructor to initialize the linked list, and one is the method for insert the node at the begin, and other one is we can insert the node some index position, and we can insert the node at end, and we can remove the node at begin. There may be a situation we can remove the node at middle somewhere, or we can see the situation we can remove the node at end. So these are the different cases will be available, and we need to know how to write all these methods. And now size of LL is returned the current size of the linked list, and print LL returns the number of nodes, the number of elements that we can print it. Now we have to write all these functions while creating a linked list, any kind of linked list. Now let us discuss one by one how the linked list is going to create. Now this is the node structure. Let's say this is the node structure of the linked list. So first of all we need to create a class for the node. Okay, class node, and now initialize the node values or node parts in the constructor. So the constructor def double underscore init constructor self comma data. So now self is the default argument and data is an actual data that we are going to insert into the node. Okay, now the first one is self dot data is equivalent to data. So whatever the data that we are going to insert, that we are going to store into the data partition, means the first partition. And the self dot next is nothing but the address of the node. First initially it will be null. Now you can see, now I'm going to write a simple node. So there are two partitions. Now let us assume this is the node data and this is the node next. So node next must be, initially it will be null. So now what is the meaning of this? We have created a node and the node next is null initially. Now you understand? So this is the basic implementation of the node in a single linked list. Okay, there are two partitions, one is the data partition, other one is none initially, and after inserting one by one we can store the address of the next node and we can establish the connection if there is node next, but initially there is no node, so make it as a null. Now this is the node structure that you can see. Now let us know how to create a single linked list one by one, how to create nodes one by one. Now, this is the class for writing the operations of the linked list. This is the class for writing the operations. So now, this is the constructor for assigning head pointer as a none, because we are creating the nodes one by one. So initially the head is none, means there is no linked list initially, it is a none actually. Okay, now we are going to write one more function, insert. We are inserting the nodes one by one. So the function name is insert. What we are inserting actually? Data. Self is a default keyword. So now we understand. Now coming to the next one, we are going to create a new node is equivalent to node data. Node data will call the node function, node class, which is already written. Okay, node is the class which is already written, which contains the data. Okay, now the new node will be created with node class. Node class contains two partitions, one is the data, other one is the null. Now while inserting the elements one by one, just check it out whether the head pointer is there or not. If self dot head is there, means there are some elements in the linked list. So that assign a temporary variable, take a temporary variable to move forward to the next node. Okay, because we can't move the starting node to the next, so that we are assigning the first node to the temporary variable, just moving to the next node. Now while temp dot next, while temp dot next means what, ma? If there is a node, if there is a node next, then increment temp by 1 and temp dot next. So later it will be repeated until to reach the last node. When the temp dot next is not there, then the control will come out of the loop and temp dot next is equivalent to new node. So I will show diagrammatically. You can see, let us assume there are 3 nodes, okay, with some data. So I'm going to store a data A. Now there is one more node, okay, that is B. Let's consider that is B. Okay, now let imagine that the address of B will going to store here, and the address of B address is null because there is no next node. Let's imagine that there are 2 nodes. So while inserting one by one, just cross verify whether self dot head is there or not. Anyway, there is a node, starting node, there is a head pointer that which is already there. So now if self dot head is there, the meaning is if self dot head is there, take a temporary variable, assign a temporary variable to the node head. Okay, now what we are doing here, ma? Just we are taking a temporary variable for the given node. Okay, next we are checking temp next. Temp next is null. If the temp next is null, now we are going to assign, because we need to cross verify where is the last node? In the last node only we are going to assign. Now, while temp next is there, this first node temp next is there, then temp will be incremented by 1. Now we can see, now the temp will be moved to next position, because now there is a temp next, so that temp will be moved to next. Okay, now the temp will be incremented by 1. Now the temp is here. Now when the temp next, when the temp next, when the temp next is available for this node, no, temp next is null initially. Here, come here in this step, so that this loop will exit. Now the control will come to the next part, that is temp next. What is temp next? Null, right? Now the temp next is equivalent to new node, because we have already created a new node. Now that new node will going to add. Let us assume this new node is C. Okay, the temp next, and then means here the address of C will going to store here. Okay, now this is, otherwise make if there is a self dot head, we are going with all these steps now. If there is a self dot head, we are going to with the all the steps. Means if there is a first node, we are going with the steps. If there is no elements in the linked list, make that new node as a first node. That is the meaning of this last step. Else, make that create a new node as a head. So this is what exactly how to create a linked list. Now you understand? Now to the next one, insert a node at begin. Insert the node at end, sorry. Okay, now we are going to insert the node at end. How? Let us assume there are some elements in the linked list. Okay, now create a new node. Okay, create a new node with node data, and if not self dot head, if self dot is not available, make that new node as a head. As a programmer, we need to think a negative side also, because computer doesn't know if this linked list is there or not. So we need to check it out. We need to cross verify whether the self dot head is available or not. If the self dot head is available, so we can add it, we can add the elements one by one from there. If the self dot head is not available, then we can make the new node as a self dot head. That is the meaning of this line. Otherwise, if self dot head is available, we are not available, then we are making the new node as a head. Otherwise, we are going to assign a self dot head to the temporary variable, and we are going to move until not none. Okay, so until not now none means not null, then we are going to increment temp by 1. Now later when we are reaching to the last node, that node next is equivalent to new node. The meaning of this statement is, this program is just we are adding the node at the end. Okay? We are adding this node at end. So now you can see the diagrammatical representation. Insert the node at the end. So A, B, C, D are the elements which is already there. Now we are going to add E node at the end. So how do you add the E node at the end? First we need to find out where is the null. So if you want to reach to the null, because D next is null. So A next is the address of B, B next is the address of C, C next is the address of D, and D next is null actually, because there is no element later. So that when the next element next is null, that we are going to connect here. Okay. So now how do you identify where is the null? And take a temporary variable and move to the null one by one by incrementing. Then the temp next, temp is D. Now temp next is new node. So now you can see the last statement. So temp next is new node, the temp next will be new node, and now new node next will be null, obviously, because it is the last node. It is a simple way to connect this tool links. Okay, now first of all, let us understand how we are going to add, how we are connecting the last node to the new node. Just temp next, the only line that you need to remember, the temp next is equivalent to new node, simple. Okay, now this is what exactly how to insert the element or node at the end. You can see the diagram. So insert some position, you can see first of all, assign a temporary variable to this first node, and you can reach up to position -1. For example, you can say A, B, C, D, but I wanted to insert in between B and C. And what is the memory location? A is 0, let us assume A is 0 and B is 1 and this is 2 and this is 3. So whatever the node I am going to insert, I want to make it as a 2, let us assume. Okay, I wanted to make this node at second position. In this case, you need to travel up to position -1. Position -1 means what? You need to reach up to 1th location. Okay, so you can stay here, then you can, this node next must be a new node, that new node next must be that node. Okay, then how do you write a code for this? You can reach up to range 0 to position -1. Okay, so the range from 0 to position -1 and 0 to 1. Okay, now temp is equivalent to temp next. You can reach up to the previous node of the memory location. The new node next is equivalent to temp next. First of all, you need to connect this new node next to the temp next. Temp next, what is there? Now the temp is here, right? Now you can reach up to position -1. Now temp is here. Okay, now the temp is here. That what is temp next, ma? C. Okay, so first of all, you need to connect E with temp next. Okay, the node E next, temp next. The new node next is equivalent to temp next. Now the connection will be established here, and later this connection gone, right? Later temp next is equivalent to new node now. Okay, now come out of the loop, then you can connect this temp next is equivalent to new node. Okay, simple. So the new node next is equivalent temp next, and now the temp next is equivalent to new node. Now this E node will be stored in a second location. So you can reach up to position -1 to keep, because you need to connect from here, so that you wait up to position -1. So this is what exactly the insert the node at end, some position, sorry. Okay, now print. So suddenly after inserting, after deletion, after doing any operation, you need to display one by one. Display function is also called as traverse. This is actually, I took the display function as a print LL. Now this is also called as a traverse function. So traverse is nothing but visiting all the nodes one by one. Okay, first let us assume how to visit, take it, because we can't move the head pointer to next, right? So that assign head pointer to temp first. Now while temp, print temp data. While temp is there, okay, then print temp data, and temp will be incremented by 1. While temp, then print temp data. So this loop gets repeated until to reach next null. Okay, now here there is a step-by-step procedure. You can see, initialize the current node with head and use the while loop to traverse from the linked list until to reach the last node, until none. Each iteration, now you can see the third step, for each iteration, the print the data of the current node. After printing, update current node to the next node in the list by setting the current node to current node next. Okay, it's simple. Current node is nothing but the template, assume the temp. Okay, now it's simple to print all the data one by one. First, we need to assign the first node to the temp, and you can find out if there is a temp, print temp data, temp should be incremented by next. Similarly, until to reach last node, we are going to print the data. It's simple. It is also called as a traverse function. Now, thank you all. I hope you understand. Thank you so much.